Hi guys, and welcome back to this part 2 of access control lists. So I've literally just left off from access control list part 1 video just a moment ago, and you would have watched, and if you did join me for that, you would have seen that I added an access control list to router 1. So let me just pop back into router 1 for a moment. You can see that this is literally just where I left off. And I was just mentioning at the very start of the last video that we can indeed see, we can use our show commands to view access control lists. So in this case, I can hit my up arrow and I can see exactly what's going on with regards to the access control list scene. But I can also see, if I go show IP interface, and instead of brief, I'll go fast Ethernet 0/0, what I'll also be able to see is, I'll be able to see that basically there's an inbound access list. So that's set to 1. So in other words, there's an access list set up there. So that's important to note here, guys. Now again, in this particular section, what I want to do is I want to go on to activity 2. So what if I said I wanted to get rid of that access list? So in this case, what I could do is I could go conft, I could go into interface fast Ethernet 0/0, and what I could do is simply, there's a couple of different things. I could just get rid of it, okay? And if you weren't sure what it was, what that line was, you could do a do show run. So basically you could go under, find, for example, interface 0/0, and I can see there's the line there. So what I could do is I could just literally copy that. Now that I'm under that interface, I could just hit the no word and then basically paste. And what that's going to do is essentially going to take it off or stop it now running on that interface. Now again, rather than just, this is now both PC0 and PC1 will now be able to ping both web FTP server again. So again, there was always PC1 could, but basically we were stopping, weren't we, PC0. If I try and ping again now, this should work again because I've essentially stopped it. I've stopped it running on this particular, I've stopped the interface checking that on this fast Ethernet 0/0. So this should essentially work again. There we can see it's working again. Now again, I always like to tidy up as well. I always like to say, well actually, even though I've taken it off the interface, the access list is still there. So again, if I go show access list 1, I can still see it's there. So what you could do is just go conft and say no access list 1, just to clean up and to take it off completely. So again, now if I say show access list, it's now gone. Okay, so once I've done that little bit of housekeeping or tidying up, I now need to look at activity 2, guys. So what I now need to do is I need to say, okay, let's read this, let's create a plan for ourselves, let's create the access control list, and then let's apply it to the appropriate interface. So let's have a read carefully of what they want us to do here. So activity 2, add a packet filter at router 2's inbound interface. So I can see the inbound interface in this case is going to be, now again, there's actually a number of different inbound interfaces, but I'm going to explain what I'm looking to achieve here. Okay, so where would be the inbound interfaces? Well, we've got a number of them. There's basically serial 000s here. I can see there's serial 001, and I can see there's also a fast Ethernet 0/1. So there's 3 interfaces here. There's inbound interfaces for all of those. Now what I want to do is, and I'm going to change this up slightly. I'm going to say for the serial 0/0/0 interface. Now, why do I want to do it for there? Because again, what I want to do is I want to be able to permit PC1's traffic. So I want to be able to permit PC1's traffic to go out to the server, and I want to be able to go over to PC3 here as well. However, I want to stop everyone else on this 192.168.10.0/24 subnet from basically getting any further. So the 10. In this case, 11 address should be able to go over to PC2, but it should stop. It shouldn't be allowed to get to, for example, the web server, or it shouldn't be able to be allowed to get over to this PC3. Okay, so also you might say, is there any other traffic that should be allowed? Well, also here we can see permit all other traffic. So again, if PC2 wants to communicate with the FTP server or the web server, it should be able to, and it should be able to ping, for example, PC3. So I don't want to impact other traffic. And this is the thing with access control lists, guys. When you roll out these, I always say, do it on paper first, Then what you can do is you can obviously look at it very carefully on paper. Then what you can do is you can then start to apply it. Now again, if this was a production network, guys, you've got to be very, very careful with this, because again, by being too restrictive with these access control lists, you could stop actually traffic moving across the network very, very easily if you misconfigure this. Okay, so let's have a look at now going through and setting this up. So the first thing I'm going to do is I'm going to jump in over, well, even before I jump into the router, always good practice, guys, to say, okay, let's see. So again, I'm going to permit PC1's traffic. So that's going to be able to get through. So the first thing I might do is I might just do a quick ping, guys, to see, can I ping, for example, my friend over here, PC3. So again, I'm going to ping, in this case, instead of 20.254, I'm going to say 30.10. Okay, and I can see I'm getting across here. What I might also do, guys, is I might try and ping from PC0 over to here, PC3. Let's see if that works. So let's go over here. Let's bring over our command prompt, and I just want to see, can I ping from over here? So 30.10. Okay, so again, I'm trying to ping, and it looks good. I'm able to ping. Now, in just a few moments, guys, what I'm essentially going to be doing is I'm going to be stopping this traffic. So again, PC0, because it's on the 10 network, okay, and it's not 10.10 PC1, I'm going to basically block that machine from getting over to PC3. So let's do it. Let's configure our interface. So in this case, what I want to do is, and I can see serial 0 is in up state, so that's good. Now what I'm going to do is I'm going to jump onto router 2. And I'm going to keep looking at those rules that I want to do. I want to permit PC1's traffic. So what I'm going to do is I'm going to say enable to move to from user to enable mode. I'm going to go conft, and what I'm now going to do is I'm going to add this permit statement. So I'm going to create another access control list. Again, I can choose between number 1 up to 99. I could choose number 10, number 20, number 5. But again, I'm just going to keep it simple. Choose number 1. It's available. And then what I'm going to say is, I want to permit host, because again, I want to allow PC1's traffic to always flow through this. So I'm going to say 192.168 dot, for example, 10.10. Now, just one thing I want to mention here, guys, is there's many different ways to do this. And in a moment, we'll talk about wildcard masks, okay? We could use a wildcard mask, but I'm simply using at the moment this host command to just refer to this one PC. So once I've done that, guys, what I'm going to do is press enter. Now what I want to say is I want to basically allow just this machine here, but I want to deny everyone else on the 10 network. So how could I do that? What I could do here, guys, is I could come in here and I could say access list 1, deny, and I could say host, and I could say 192.168.10.11. So this would be this guy over here, and I could press enter. And then I could type in another statement, access list 1, deny host 192.168.10.9, and I could say enter. Then I could go deny host 192.168.10.8. and go all the way through 7, 6, 5, 4, 3, all the way through here, guys, and then go from 12, 13, 14, 15, 16. You might be saying, that's going to take a long time. Is there an easier way to do this? And the answer to that question is, yes, there is. So what I can actually do here, and this is when we need to talk a little bit about wildcard masks, I need to understand again my subnetting. So again, with this network here, guys, let's just do this out with a little chart over here. I know I'm on the 192.168.10.0/24 network. So again, what's the subnet mask for that? The subnet mask is 255.255.255.0. Isn't that right? It's got a /24 mask. What does that mean? It means /24 means 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now again, it's very, very easy to get this wrong. Okay, so please bear with me, but there should be 24 ones there indicating the /24 followed by 8 zeros. Now here's the thing, and this is the big jump I want you to do with me here, guys. A wildcard mask is the inverse of a subnet mask. So what we're going to do is essentially flip the bits. for this wildcard mask. So what we're going to see actually, guys, is instead of having 24 ones followed by 8 zeros, what we're actually going to be doing is we're going to be putting 24 zeros followed by 8 ones. So what we're going to do is we're going to say 1, 2, 3, 4, 5, 6, 7, 8, followed by 1, 2, 3, 4, 5, 6, 7, 8. And I hope that I'm getting the correct amount of zeros here. And 1, 2, 3, 4, 5, 6, 7, 8. And then what we're going to follow this up with is 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. So what we now have, guys, is we have basically now, this is called our wildcard mask. And what this is going to do is, this is representing how we're going to write this out in just a moment on our command line. So what this essentially means is 8 zeros is going to basically mean 0 in decimal. 8 zeros, again, in the second octet here, it's going to be 0 in decimal. All zeros again, what's that going to mean? That's going to mean, it's going to be, and I think I'm missing a 0 there, guys, but that's going to be basically 0. And then finally, what's 8 ones in decimal? Well, it's going to equal 255. Okay, so what we've represented, this usual, our subnet mask of /24 would be 255.255.255.0. Using access control lists, we do the inverse of this. We use wildcard masks. And how this works is we invert the subnet mask. And this is how we get this dotted decimal value for a wildcard mask of 0.0.0.255. So what I'm now going to do, guys, is on my command line, what I'm going to do is I'm going to say, for this, I'm in the wrong router there. I need to make sure that I'm in the correct router. For router 2, what I'm going to say is I want to basically deny all of the 10 network. So this is the 192.168.10.0 network, followed by a wildcard mask. And if I put the question mark here, look what it's asking me. Wildcard mask bits. What are they? This is going to be 0.0.0. Hold on, make sure I get this correct. 255. Let's double check there, guys. And I'm just going to make that nice and big so I can see it on one line. So what is this essentially saying, guys? It's saying basically in access list 1, use a deny statement, but this time I'm not just going to deny one computer, guys. I'm denying this whole subnet. So what this basically is saying, guys, this wildcard mask is very powerful. What it's saying is match exactly with this 0 bit. It's saying match exactly 192. It's basically saying in the next 0, match exactly 168. Then in the next 0, it's saying match exactly basically 10, the 10 network. And then it's saying for 255, it's basically saying I don't care what the host bits are. So essentially it's saying I care about, it's that I want to block anything on the 192.168.10 dot something network. And once I press enter to that, guys, that's now gone into my access control list. Now the one last thing that I will do, guys, is again, usually what I say is it's going to deny everything after that. Now in this case, that's okay. It's this implicit deny. Okay, but if I did not do this, guys, because it's up here, I could potentially block, by not putting in a permit any here, guys, I could potentially block all of these networks too. So what I'm going to do is I'm going to put one more statement here to say access list 1, and I'm going to say permit any. Okay, now guys, that's my access list sorted. If I want to have a look at that now, I could go show access list, and again I could say 1. And here we can see is I'm saying permit host, basically 192.168.10.10, and then I'm basically saying as the next statement, deny everyone on this 192.168.10 dot anything network. And then I'm basically saying permit anyone else. Now again, you might be saying, but hold on a second, you're denying the network. Why would this host be allowed through? But remember, the order here is really, really important on an access control list, guys. So again, by me having this permit statement above this deny statement, that's a really important thing. If I had this permit host below this, well, again, guys, what I'd be essentially doing is I could be, again, stopping this from working. Okay, so what I'm going to do is I'm now going to do the last thing. I'm going to apply this access control list. So I'm going to go conf t, and I need to apply it on, and this is giving me the rule here, and we set the rules up above, inbound to serial 000. So I'm going to go interface serial 0/0/0, and I'm going to say IP access group 1. So I'm going to match it to my access list of 1, and I'm going to say inbound. And what this is going to do now, guys, is it's going to apply this access list to the inbound interface of serial 000. So let's now think about what this will do. I'm now saying that PC1, I'm basically allowing host 192.168.10.10 true when traffic comes through this router. So again, when it sees a source IP address, it says, oh, that's okay, you're allowed true because I'm permitting. But anyone else on this network, if it's not 10.10, anyone else, like for example 10.11, it should be basically denying and saying, sorry, I'm not going to allow you true. So let's first test, can we ping still from PC1 over to PC3? It should still work, shouldn't it? So let's go over here. Let's go to, for example, our ping, and let's ping 192.168.30.10. So that's our friend here, PC3. This should work. And here we can see it's working, which is excellent. Now, guys, what I should be able to see if I go over and I try to ping from PC0 to, for example, PC3, will it work? Well, let's give it a try, guys. What's your expectations here? Well, actually, this should fail, shouldn't it? This should get blocked by this interface. And this interface's IP address is 10.1.1.2. So this interface should be saying, hey, hold on a second. You're from the 192.168.10 network. You're not 10.10, so you should be blocked. Let's give it a try, guys. And here we can see, guys, exactly what we're hoping for. It's now blocking. So we can see that, again, 10.1.1.2 is blocking this traffic getting through to our PC3, I think it was, yes. Okay, one last thing that we should do, guys, is we should make sure that PC2 can indeed ping. So again, can we ping from PC2 over to our friend? We should still be able to. Again, that permit all should allow us true. So again, let's try it. And again, it's allowing us true. If we want to check the router, guys, so again, if we want to check this, the statistics, we could go show access list 1. Okay, and here we can see, guys, have a look at this. So again, it's matching. We can see there's matching statements going through here. So again, we can see that there's been some traffic that's basically hit this. We can see other traffic, and we can see even, for example, guys, there might be other traffic communicating that through this network. Now, this could be routing protocols and so forth. So we need to think about other traffic. We want to allow that traffic through. We don't want to block any other particular traffic. We just want to do our particular jobs. So in this case, we can see that this permit any traffic. That would have matched some of the packets that basically PC2 was sending. Again, if I continue, guys, to send traffic through from PC0, so again, if I just have a quick look, so again, only so far I sent 4 packets. If I go back in here and ping some more, maybe, for example, instead of pinging my router, if I ping the web server, ping this guy here, it should also progress through. So again, it should match. So again, if I try to ping here, so again, this is the 10 network, this should also get denied. So this ticker should tick up. So if I try to go to 20.254, will this allow it? No, because again, remember, it's going to block the traffic inbound. So it shouldn't allow it to get to this interface. So this should go and increase. Let's see. Again, look, we're getting blocked. It's not allowing us to get through. And again, if I hit the up arrow, press enter, I should see more denied traffic. And here we can see, guys, can you see that? I'm getting more denied traffic going through here. Okay, so guys, that's just to summarize a little bit of standard, basically, access control lists. And you can see the power there of these access control lists and how they can basically filter traffic. And again, we can apply them at various different spots throughout our network. In the previous exercise, we applied them on router 1. In this exercise, we basically applied them on router 2. If we want more sophistication, so if we want to filter based on other parameters like destination host IP address, well, that's when we would need to use our extended access control lists. And what I'll do, guys, is in the future, I'll do a quick little tutorial on those. But for now, thank you very much for viewing, and I hope it was beneficial for you. Thanks guys, and see you soon.